when you do these, on Monday, we're not going to grade the assignment. On Monday, I'm going to come and help the ones that you need help on, okay? And also on Monday, we're going to do a gallery walk and like give feedback on the others. We just didn't have time to do it today. Do that on Monday too, in the hallway. But on Monday, I'm going to come around and help you. But if you come up to me and your paper looks like this and you say, I need help, I'm going to say, what did you try? Does this look like this person tried anything? If you did not try anything, I can't help you. You have to always try something. So maybe it's, I turned everything into sines and cosines. Like, there's got to be something on your paper when you come up and say, I need help. I've done this, but I don't know where to go from here. Or I've done this, I'm not sure if I'm doing it right because it doesn't equal what it's supposed to equal. But you have to try something on all of these. If you don't do your homework, then I'm not going to help you. You know what I'm saying? All right, so you have to try something. Even if you try something, you might learn, oh, that's the wrong thing to do. I won't do that again. You're going to learn by mistakes as well. So we're going to do, what do we got? 6 questions for example. So verify the identities. What I like to do first is decide which side looks more complicated. The side that looks more complicated is actually the side you want to do stuff to. Trust me. Which of these sides should I work with? Definitely. So what I do to the right is I put a box around it and I say, I'm not going to touch that. It's going to stay sine squared x the whole time. That's my goal, to make it say sine squared x. That's my goal. I'm not going to touch that. And on the left side, I'm going to start thinking about how can I possibly make secant into just a sine squared x. And when I look at secant, I'm thinking that's cosine. That doesn't immediately switch over. So then I start thinking, all right, well maybe secant squared x minus 1 is a thing, maybe. Where you start looking. The Pythagorean ones, right? So we got those lists of Pythagorean ones. Is secant squared x minus 1 a thing? Yes. What is it? Tangent squared x over secant squared x. So there's my first step. As soon as we put tangent in there, my mind starts thinking, well, tangent is sine over cosine, so now I've got a sine in there somewhere. What should I do next? Do that, what I just said, what was in my mind, because I want to keep this sine squared in my head at all times. So I want to say, I got to get to sine squared. So now I'm going to take tangent and write it as sine squared x over cosine squared x, which is over, I don't know, am I? 1 over cosine? Now, do you notice how I made like the main fraction a big old bar? Because I know what happens. Halfway through your work, you like forget what was what. You use the wrong one as the main division bar, and then things are wrong. So I try to make myself not make those silly mistakes. So now, what I'm doing is I have a fraction, and I'm dividing by another fraction. You can't divide by fractions. What do you do instead? So instead of dividing by 1 over cosine squared, we're going to take sine squared x over cosine squared x, multiply it by the reciprocal, cosine squared x over 1. So if I multiply those, I multiply straight across. What happens when I multiply? Cosines cancel. I can cancel if there's multiplication. When can I not cancel? Addition and subtraction, right? Don't be that person. So I get sine squared. Ooh, that's what I wanted. Yay! So now I'm done. It's like a big surprise. What? I got it? Okay, let's try another one. Now, what I don't want is I don't want everybody just yelling out answers. I'd rather start calling on you because I want other people to have the opportunity to like think for themselves. You know, as soon as somebody yells out the answer, you stop thinking. You're not going to be able to do this on your own if you aren't practicing it on your own. So the first thing I want you to do is I want you to decide which side we should box in, which side What's a little bit easier? Which side looks more simplified? Which one should we box in? I'm going to box in the 2 cosecant squared x because that only has 2 times something. Over here I've got subtraction, addition, division. Like I got a lot of stuff happening on that side. And my mind should be thinking, I need to get down to 1 term. That means I'm going to have to add fractions together. I'm going to have to do that. I also can't have fractions when I'm done either. Or it might be. What is cosecant? Like 1 over sine. So you could be thinking ahead. This is like 2 times 1 over sine squared x. You could be thinking that, but that you don't write that on this side, but you can think it. I might help you. Okay. What do I need to do? Who has an idea? It doesn't have to be how I do it. It's just who has an idea of what I need to do. Why would I be doing that? Because I need to add them together in their fractions. And to add anything in math, we have to have like terms. So with fractions, common denominators. Okay, here's the part that we did this in algebra 2. Here's the part that people didn't do so great on in algebra 2. Is trying to add stuff like this, common denominators. I'm going to give you an example that's not with cosines, just totally with numbers. How would I find the common denominator for that?
Multiply 3 by 5 and 5 by 3.
Why didn't I just like add 2 onto this? Oh, yeah, that's what people did last year, but not you guys, because not you. I'm sure you did. But not you did. No. Anyway, it's not paying attention. Okay, anyway. We're all staring at you back here. One second. This one here is like 1 plus a number or 1 minus a number. In order for them to be to have anything in common, they would have to have a factor in common. There's nothing being multiplied here. Just like this. 3 is just 3 times 1, and 5 is 5 times 1. There's nothing like being multiplied. They have no factors in common. So yeah, we're going to multiply by each other, but I don't just multiply this by 3, do I? What do I actually multiply by? 3 over 3, because I'm multiplying by a value of 1, so it doesn't change the value. So over here, I'm multiplying by 5 over 5. You have to multiply by the same thing on top of bottom. That's how you find common denominators. So we're going to do that with this one. Only it's going to look a little bit more complicated. So I have to multiply by each other. So I've got, I'm going to multiply this one by 1 plus cosine x over 1 plus cosine x. And then we have a 1 minus cosine x on the bottom still. And then my second one, I'm going to multiply by 1 minus cosine x over 1 minus cosine x. So do I have a common denominator? It's the same. For my next step, I'm going to simplify that common denominator. We're going to multiply them together by FOIL. By the way, what do you notice about these 2 binomials? Because 1 is plus, 1 is minus, but they're all the same terms. When I multiply them together, they will be a difference of squares. Do you know what they're called? Like vocabulary, does everybody know that term, that vocab term that means like 2 binomials, same stuff, 1 plus 1 minus. When you multiply them, you get difference of squares. Does anybody know what that's called? You will want to start spelling it. C O N conjugates. Yeah, conjugates. You're close. You're close. That, I think that might be the fastest anybody got close to it today. Conjugates. You're going to keep hearing me say that word over and over again, but yeah, they're conjugates, and that means when you multiply them together, we'll have a difference of squares. The inside and the outside terms cancel out. So if you don't remember anything I'm saying right now, FOIL all that together. If you remember what I'm saying, I can skip to the final product, because I know that rule. But if you don't remember, you're going to have to do it on your, you're going to have to multiply that on your own. And then on top, we just add our numerators. What do we look for now? Or what do we do next? Combine like terms in the numerator. So I got 1 and a 1. I've got cosine and a minus cosine, so this will cancel out. 1 plus 1 is 2. Ooh, I need a 2, don't I? What also do I need? I need cosecant, but before I get cosecant, remember what I said I'm thinking about? I need a sine squared on the bottom, don't I? Do I have a sine squared on the bottom by any chance?
Yes.
Yeah, that's up if I remember an identity that says 1 minus cosine squared x is sine squared x. So now if I move that sine squared x up, I get 2 cosecant squared x. Yay. When you're ready to go on, turn your page over. Well, 1, just ignore this 2. 1 over sine squared x is the same thing as cosecant squared x.
Okay.
And then 2 times that.
Okay. Got it. Thank you.
Fun little puzzle. Well, if all your faces agreed with me on that. Which side should be boxed in? One, okay. Now, I'm not saying you couldn't get the 1 to eventually look like that. It's just a lot harder. I bet you I could do it, but it's a lot harder. So we're going to start with this side. I want you to think for yourself. And you can try something. Then we'll go over it. What time are we at? 55? No, yes. Oh, it is 55. My bad. I'm wrong. Nobody's done with my idea yet. It's good. If you've done that one. Here, try something. Drop something. There's 2, 3, 4. 5 years of work. Just start reading through those. See what you could do. Okay, so I walked around, and a lot of you went straight to number 4. Okay? I'm not going to do number 4. I'm not going to change it all into sines and cosines. That does not mean you can't do it that way. Did anybody get the answer doing it? Change it to sines and cosines? Okay, so I can put up, whoever got the answer, I can put that work up, and we can have 2 versions of it. But I'm not going to use my last resort yet. What I'm going to do for this one is notice that these are 2 terms, and both terms have cotangent squared. So I'm going to factor out the cotangent squared. If you didn't do it that way, that does not mean erase and change all your answer. Because I'll put up the other way to do it too, with one of those that did it that way. So but I'm going to take out cotangent squared, and then I'm going to be left with secant squared x minus 1. And then when I do that, secant squared x minus 1 is a Pythagorean identity, which is tangent squared. And then cotangent squared is 1 over tangent squared. Which is 1.
Maybe we figure just write that minus cotangent, like the whole line.
And then Julie did it the other way. So Julie did hers by changing everything to like sines and cosines. And I'm putting in the equal sign so you can see like this is the first line totally. Here's your cotangent. She changed these into sines and cosines and canceled the cosines. She changed cotangent into cosine over sine. And then these had common denominators. So put them together. 1 minus cosine squared x is sine squared x. Canceled and got 1. Okay, so if you did it that way, it works as well. All right, the next one. When you look at this and you think about which side is more complicated, you might not be sure. But I'll tell you, I think the side that's more complicated is the side that has a cosine and a sine on it, where the other side only has cosine on it. So that's why I think this side I'm going to box in and work with the side that has the cosine and the sine. Yeah.
We boxed on the other side, sorry.
Yeah, you can get it the other way as well. Like there's different ways of doing all of these, which makes your teacher's job of assessing it a lot harder. Heads up. Be nice. Okay. All right, so what I'm going to do is I'm going to have to somehow get rid of sine squared x and make it into another cosine because I need 2 cosines. So since it's squared, I'm going to go to that Pythagorean page, and I notice that sine squared x is the same thing as 1 minus cosine squared x. So I switched out sine squared x, made it 1 minus cosine squared x. Then I'm going to distribute that negative sign, which changes the cosine to positive. And since we have a cosine squared x, adding another cosine squared x, we now have 2 cosine squared x minus 1. Okay, so that next one you're looking at, you're trying to decide which side to box in. I think subtraction is more complicated than division or multiplication. So I'm going to box in this side. That does not mean you couldn't box in the other side, but that's the side I'm going to box in and work with right now. I'm also going to think to myself, just kind of thinking, that 1 over secant x tangent x is the same thing as cosine x cotangent x. I'm just going to kind of think that as well, that I'm not changing the left side, but that might help me go in the correct direction. So then we look at the right side, cosecant x minus sine x. They both have something in common. What does cosecant x and sine x both have to do with? Sine, right? So I'm going to change. There's no sin in that. Somebody said, did you say sin? That wasn't you. We change cosecant x to 1 over sine x minus sine x. And I have to get rid of the subtraction sign, so I need a common denominator. So we're going to multiply both the top and bottom of that second fraction by sine x. So when I do that, I'm going to get 1 minus sine squared x over sine x. You cannot cancel those signs. Because of that minus sign right there, you cannot cancel those. Sign cannot be factored out, so leave it as is. However, 1 minus sine squared x, Pythagorean identity, is cosine squared x. So if I separate that cosine to be like cosine x over sine x, and then I go back to what I was thinking earlier, do we see a path? How do I get cotangent? All right, there's cotangent. And if I have cotangent or cosine x, cotangent x, then I have 1 over secant x, tangent x. Sorry. Okay, I've got one last one in 6 minutes. One last one. This last one, we haven't done anything with the fourths yet, so I'm going to show you something that you would recognize with fourths, maybe recognize with fourths. You ever seen something like a to the fourth minus b to the fourth? This is a difference of squares in algebra 2, where you could factor that to be two conjugates. It would be a squared plus b squared and a squared minus b squared. That's difference of squares. How can I apply that to this? Instead of a's and b's, what do we have? Cosines and sines. So I'm going to rewrite this as cosine squared x plus sine squared x multiplied by cosine squared x minus sine squared x, and then my equal sign. Now what happens? Look at what we're trying to get.
1 sine squared x is minus sine squared x.
This is 1, right?
Yeah.
And then I'm done. Cosine squared x minus sine squared x. That one looks really complicated, but it was only really 1 step. 1 and 2 steps. So I'm going to pass out your worksheet. And again, I said this on Monday. We will not grade it. So do not feel like you have to finish 26 questions. However, you should have started 26 questions. So if you get stuck, bring your questions in. All right, it also says, you'll see, you know what I'm saying? Use a separate piece of paper. You're not going to fit it all on here.